Hello students, today we'll be learning about the basic concept of stress and strain. Introduction to strength of material. So what is stress? As per the definition, it is the force of resistance offered by a body against the deformation per unit area. Mathematically, we can say it is the P, that means it is a load per unit area. For example, take a bar where P, that means load, is acting on its cross-sectional area. Okay, so here, because of this force, a resistance force is generated. This resistance force is generated against the deformation caused by the force. This resistance force for this cross-sectional area is nothing but the stress. Next, here the P is known as the load, where A is the area, which is in mm square, and P is in Newton. Load is in Newton. The unit of stress are, we can say it as Newton per meter square. We know that 1 Newton per meter square is also equal to 1 Pascal. 1 Newton per mm square is equal to 1 megapascal. And 1 kilonewton per mm square equal to 1 gigapascal. 1 megapascal is equal to 10 to the power 6 Pascal, and which is equal to 10 to the power 6 Newton per meter square, as 1 Pascal equal to 1 Newton per meter square. So here we have to convert it Newton per mm square. That means we have to convert meter to mm. So here that is already 10 to the power 6 we have, and 1 meter equal to 10 to the power 3 mm. So here we have to put 10 to the power 3 and it's meter square. So 10 to the power 3 square. 10 to the power 6 divided by 10 to the power 6, that is equal to 1 Newton per mm square. Here also I have written that is 1 Newton per mm square equal to 1 megapascal. So you have to also do it for same for the gigapascal. Next is strain. As per the definition, when the load is applied on the bar, deformation occurs, as we know. This deformation per unit length is called the strain. Mathematically, how we'll express it? Uh, as the deformation falls, that means change in length occurs. So this change in length to the original length is called as your strain. Okay, so this is the strain is denoted as epsilon, and this is equal to dl by L. That means dl is the change in length and L is your original length. Okay, so strain is a unit place unit. So the different types of stresses are tensile stress, it can be compressive stress, or it can be shear stress. So in tensile stress, the bar is subjected to two equal and opposite pulls. Okay, so here you can see in the diagram. So here the bar is subjected to two equal and opposite pulls. So because of that, the stress developed in that bar is called as your tensile stress. It is nothing but the tensile force to the cross-sectional area. Similarly, for the compressive stress, that means the bar is subjected to two equal and opposite pulls. Okay, so because of this two equal and opposite pulls, the stress developed in that bar is called as your compressive stress. Mathematically, it can be equal to compressive force to the cross-sectional area. Next, this tensile and compressive stress are called as your normal stress. Next is shear stress always acts coplanar with the cross-section. Here you can see in the diagram, this P, this force is applied coplanar with that cross-sectional area. Because of this force, an equivalent force will also generate a resultant force. So if we see it in 2D diagram, so here you can see, so this will be a force. For the equilibrium, there will be another force also. Okay, so to resist the rotation, these two forces will be also there. Okay, so the shear stress always causes the tearing of the metal. Okay, the shear stress is nothing but the shear force per unit area. Or the shear stress is also denoted as tau here. Okay. Then Hooke's law. Okay, so according to the definition, it states that When a material is loaded within the elastic limit, the stress is directly proportional to the corresponding strain. Okay, so then again there is a term that is elastic limit. What is elastic limit? So to know that elastic limit, we have to know what is the elasticity. As we know that if a bar is loaded, then it occurs the deformation. Then deformation occurs. So when we remove that load, if that deformation will revert back, or if that bar will regain its original shape and size, this is called as this property is known as the elastic property. What is the elastic limit? So it is the limiting value of force we can give to a material upon removal of which the material regain its original shape and size. So elastic limit can be calculated for a material by the tensile testing of that material. So for the ductile material, this is the diagram. Okay. So this up to this. So in the y-axis, there is a stress, and in x-axis, there will be strain. There will be, if we remove the proportional, then there will be a constant. So this constant is known as the Young's modulus or modulus of elasticity. So here you can see the stress is equal to Young's modulus into strain. So here you can get the Young's modulus or modulus of elasticity is equal to stress divided by strain. If we put the formula for stress and strain, we will get this equation. That is Young's modulus is equal to PL by A into DL. So DL is the deformation or elongation, L is the original length, P is the load applied to it, then A is the area of the cross section. Here you can find out what is the DL. So DL equal to PL by AE. Okay, so this formula will be utilized in further calculation.